Good morning, guys. So I'm going to make you a short video on how to distinguish between ionic compounds, covalent compounds, and more specifically, how to name each one of those, okay? Okay, so let me go ahead and get my list started here. Okay, so what we're looking at here is ionic compounds and covalent compounds, and we're going to have to figure out how to tell the difference between the two, okay? So I'm going to list a compound here. Okay, and then on the other side, I'm going to do the same thing. Okay, now in this case, you're going to know, I'm telling you which one is which, because we need to understand the difference and how to tell when looking at a compound whether or not it's covalent or ionic. Okay, so here's the first thing we got to determine. Okay, we know that ionic compounds exist between two types of elements. Okay, they exist between metals and non-metals. So let's see, metals and non-metals. So if we look at something that is a metal to a non-metal, then we have to assume that it's going to be an ionic compound. Now, a metal is the most predominant element on the periodic table and pretty much exists everywhere on the left side of the table. So looking at your periodic table, if you notice that there is a metallic element in the compound you're working with, for example, iron, okay? Iron is a metal. Chlorine is a non-metal. So if you have a metal to a non-metal, then you know that you're looking at an ionic compound. Okay? And that's how you tell. Now, how do you know if you're working with a metal? Well, I can tell you that iron is pretty easy, right? Most people know that that's a metal. Okay, but some other elements are not so obvious, right? Like sodium. Most people don't know that sodium is a metal. So how can you tell if you're looking at a metal? Well, if you're looking at your periodic table, right? I'll show you here. Your periodic table kind of looks like this. You have one here, a couple elements here, and you have all these guys, right? So your periodic table kind of takes on this shape, right? It's not exact. I'm just kind of just drawing here. Now on your periodic table, you're going to have like a little lines that kind of jiggle like that, right? And this is where we kind of have the metalloids, okay? Pretty much everything on this side of the table, okay, is metals. These are all the metals. So if the element that you're bonding with exists anywhere on this side of the periodic table, right, you can rest assured it's going to be a metal. Now, the non-metals exist in a little area here, right? All this space over here, this is occupied by the non-metals. Okay, these are all the non-metals. So in order to have an ionic compound, you need to have an element from somewhere on this side of the table and from somewhere on this side of the table. Okay, if you have a metal element in your compound, that's how you tell the difference between ionic and covalent. Of course, they bond different ways, but we're just looking at a compound and making that determination. Now, when you look at a covalent compound, in a covalent compound, you have a non-metal element. Oh man, let me. Write that one more time, non-metal. To another non-metal, okay? Because covalent compounds are non-metals bonded to nonmetals. Okay? So when you're looking at a compound and you find that all the elements in the compound are really on this side of the periodic table, right? Then you know you're looking at a covalent compound. So once you know that you're looking at a covalent compound, then you're going to understand that obviously it's going to bond differently. Okay? Oops, that's an A. But you should be able to look at a compound and make a quick snap determination whether or not it's ionic or covalent. Okay? And that's how you tell the difference. You just have to look to see what types of elements are in the compound, and you'll be able to make that determination. So this is an ionic compound. I put metal there. I don't know why I did that. Okay? So that's it. That's pretty much what you need to look at when you're looking at ionic and covalent. Now, the reason you need to know the difference is because an ionic compound and a covalent compound has different rules for determining the name of those compounds. Okay? So let's take a look at the rules. All right. So naming ionic compounds. Rule number 1 says that the metal or the cation, which is the positive ion, always keeps its name, okay, and it's always listed first. The nonmetal or the anion is added the IDE suffix to its name as it is, and it is listed last. And when naming compounds with a transition metal, a Roman numeral must be used to denote the charge of the metal. Now, transition metals are the metals that exist in this space on your periodic table, like this big block in the middle, the D block, if you remember. Okay. Now, when we're looking at transition metals, okay, transition metals are called transition metals because they can transition from one charge to another. So a lot of those have multiple charges, okay? Don't worry, I'm gonna give you a chart that's gonna list all these charges for you, so don't stress about that. But because they have multiple charges, we have to denote with Roman numerals what charge that particular metal carries. So when we're looking at the compound, right, iron chloride. And I know that to make this compound, we had to do that crisscross, right? Remember this guy? You take this guy becomes a subscript over here. This guy becomes a subscript over here. And when you do that, you end up with this compound. See, the 1 is invisible here, and then the 2 is here. So because of this 2, I know that iron started off with a 2+ charge, right? So this is iron 2+, okay? So I'm gonna name it real quick, okay? Remember, the metal ion keeps its name, iron. This was a 2+ iron, so I'm gonna put the Roman numeral 2, okay? Iron 2, and then chlorine gets added the IDE suffix, which is chloride. So the name of this compound is iron 2 chloride. Iron 2 chloride. Okay. Let's take a look at a covalent compound. Non-metal to non-metal. So let's take a look at the rules for naming covalent compounds. When naming covalent compounds, prefixes must be used to show the quantity of each element. The last element is added the IDE suffix to the name, and only the first element is exempt from the mono prefix. Now, what prefixes are you talking about? Okay, so let's scroll up a little bit. Here are the prefixes that we use when naming compounds on the covalent side. So actually naming covalent compounds is really simple. You just have to take a look at how many of each compound is in the, how many of each element is in the compound, and then just pick the right prefix, right? Now, third rule says that only the first element is exempt from the mono prefix. So I have an invisible 1 here that tells me I have 1 carbon. But because it's the first element, I don't have to put the mono prefix, right? So for this one, to name this guy, this is going to be carbon. And then hydrogen has 4 hydrogens. So this is the prefix for 4, right? So to name this compound is going to be carbon, tetra, hydride. Because remember, it gets added that IDE prefix, suffix. So the name of this compound is carbon tetrahydride. Carbon tetrahydride. Okay. Do one more on each one just to make the concept sit in. Okay. So I'm gonna use let's see. Nickel, and then I'm gonna bond that with right? Nickel and oxygen. Now I know, right? I know that to make this compound, it took a nickel 2+ and an oxygen 2-. And I'll give you that chart, okay? So when these guys switch over, right, they make the compound nickel O2. And if these two numbers are the same, you reduce it, right, to get this one. Now, I know this, so I know that when I started this compound, I ended up with a nickel 2+. So to name this compound, it's going to be nickel 2 oxide. Nickel 2 oxide. Okay. One more example on this side. We'll do a simple one. We'll do good old-fashioned H2O, right? Water. Water is a common name, right? But the IUPAC name using these rules would be as follows. So hydrogen has 2. So what is the prefix for 2? Dihydrogen. Okay. And then there's 1 oxygen. Now remember, only the first element is exempt from the mono prefix. Every other element, you have to include it. So this would be dihydrogen monoxide. Okay. Now, here's the last bit that you need to know. Okay. If you're in a situation where you have 2 vowels together like this, right, to get monoxide, then you drop one. Okay. So this is actually dihydrogen monoxide. You see how I dropped one? So instead of it being dihydrogen monoxide, it becomes dihydrogen monoxide. Okay. And that's it. That's how you name these compounds, guys. So that's going to be the lesson for today. Okay. One side is ionic, one side is covalent. All right. If you guys have any questions, please let me know. All right. Let's see here.